All right, this video is going to be about proportions. I know we talked a little bit about this in class, but I wanted to make sure I did a little video for y'all just in case y'all need a refresher sometime during the year. So the big thing is that proportion is just an equation saying that two fractions or ratios are identical. Okay, so if a problem says things are proportional, they're saying that they're both equal to each other. If you look at the example here, 2/3 and 4/6, these are both proportional to each other because a variety of ways. We're going to go over how many different ways you can show it to prove it. One of the ones that you're most used to is, getting that common denominator. You can simplify 4/6 and make it 2/3 by dividing top and bottom by 2. All right. So that leads us to our first example. Okay. Tell whether 6/4 and 8/12 form a proportion. That is your first example we're going to look at. So in this one, we're going to look on getting a common denominator. Well, the first one, 6/4, and the second one, 8/12. The first number that comes to mind when I see this when we talk about common denominator is to actually go and make it to the bigger number. So we're going to get change 4 to a 12. The multiples of 4 are 4, 8, and 12. That's the first one they share in common. Okay. And so we're going to change this 4 to a 12 by multiplying it by 3. The only way to simplify things are multiply and divide them. So we're going to multiply the top by 3 too. 6 times 3 is 18. So now that we have a common denominator with the other fraction, we can now prove beyond all doubt that these are not proportional. There are other ways, which we're going to see a little bit later on, but this is just one of the ways, and one of the quickest and easiest ways is to get a common denominator. So if a common denominator, we can easily compare the two. Okay. The next example, we pull it up on the other screen, is a graph. So if a problem gives you a graph and it says tell whether x and y are proportional, the easiest thing to do is take the numbers within each little table and compare them. So for example, I want to compare the x graph with the y's and look at each individual line. So this will be the first one we compare. We'll do the second one, and we'll even try to do the other fraction just to make sure. We always need some more practice with fractions. So what we're going to do is set up all of these the same way. We're going to do x to y. We're going to compare the x to the y. So the x in the first one is going to be 1/2 all divided by 3. Okay. Common denominator, or the easiest way to get rid of it, looks like to me, I would just divide it. When I see a fraction in a fraction, a complex fraction, I like to divide it. So I'm going to do down here 1/2 divided by 3, which is 3 over 1. Switch it to 1/2 times 1/3 is 1/6. So this fraction here means 1/6. That is it in its simplest form. It doesn't have a fraction or decimal in it, so we're going to stick with that one. Go to the next one. Well, go figure. The one already set up for number 2 is going to be 1/6 already, because the x and the y for that one, x is 1, y is 6. So we're already, this first one and the second one are already the same. Check the third one just to be sure. Number 3, the x is 3 over 2. The second one is 9. So we're going to do another division problem. 3 over 2 divided by 9 over 1. And that becomes 3 over 2 multiplied by 1/9. Top times top, bottom times bottom gives me 3/18, which when you simplify it by dividing both by 3 becomes 1/6. So we kind of confirmed that this entire table is proportional. Okay, so everything is running through proportionally. All right, so that one's good. So that's the second way. Another way we want to look at, exit full screen, is we want to look at this cross product. Okay, this is, I want to say it's a cheating way unless you understand where it comes from, but it does work. So it says the cross products in the proportion AB equals CD. The products A times D and BC are called cross products. So what we're going to do, let's look down at this example here, numbers, a little easier to understand that way. They're cross multiplying 2 times 6. Okay, 2 times 6 is going to give us 12. Okay, then we're going to cross multiply 3 times 4, and 3 times 4 is 12. So since these are equal, we know for a fact they're proportional. Now, I hate just going through and just saying this works, so just do it. I want you to understand it. The reason why this works is if you're comparing 2/3 and 4/6, what's really happening is they're taking this 3 here and this 6 here, and they're getting a common denominator. Now, the lowest common denominator would be 6. But if you ever want to try to do it faster, you just have to, if they're trying to find a common denominator, well, why can't you just multiply these two bottom numbers? Take this 3 and this 6 and multiply them. 3 times 6 is 18. So we're going to change both of these numbers, both 2/3 will change to a denominator of 18, and 4/6 will change to 18. All right? So that we know for a fact will be a common denominator. But whatever we do to the denominator, we have to make sure we do to the numerator also. So this 3 for 2/3 here, this 3 changed to 18 by multiplying by 6, right? Because 3 times 6 is 18. So you have to do it to the numerator. 2 times 6 is 12. Okay? You got to do the same thing to the 6 down here. 6 changed to 18 because we multiplied it by the 3 of 2/3. So multiply the 4 times 3, that gives you 12. Okay? So now we've shown right now that they're both equal. You notice that this 12 is the same 12 we had in the previous example over here. 2 times 6 is 12, it is 4 is 12. We get the same thing, but at least you see why it happened. We just got a common denominator. We just kind of cheated and used that method a little bit quicker. All right. The last little puzzle piece we're going to look at is example 3 right here. Little application. All right. So it says you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? My first question for you is, what does it mean when something's proportional? Okay. What does that mean in this problem? I'm not going to give you this answer, but if you're watching this video when you come into class, I want you to be able to answer that. What does it mean to be proportional for this example? So looking at the first one, they're doing 4 laps, okay? 4 laps in 2.4 minutes, okay? But you complete a total of 16 laps in 12 minutes. So I'm running my stats out, trying to organize everything that I have here, okay? So I'm going to set up some ratios, and then I can make some proportions. They want to know, are these ratios, these examples, are they proportional? So let's set it up a little easier. All right, I'm going to put minutes on top for the first one. So in 2.4 minutes, I did 4 laps. Okay? Is this equal to the 12 minutes that I did? Okay, those 16 laps. At first glance, maybe you see it, maybe you don't. But I already see 2 different ways that pop into my head. One is there's 4 laps here, and I'm going to go ahead and change it to 16 by multiplying by 4. It's 4 times as many laps. So if it's proportional, technically I should be able to take this 2.4 and multiply it by 4. And if it's proportional, if I maintain that speed throughout the race, okay, then they're proportional. So 2.4 multiplied by 4, that's 16. 4 times 2 is 8 is 9. 9.6. So I actually did, if I maintain the first one, I could do 9.6 minutes. I should do 16 laps. So I just proved right here that we did not maintain the same exact pace. Okay, I can prove that right there. I actually slowed down throughout the race. The other way, the faster way, you could have done the cross multiplication again. You could have done 2.4 times 16. You would have gotten the number relatively close to 30, a little bit above 32. Well, you do 4 times 12, and just by looking at it, 4 times 12 is 48, so you're not even close there. So we know we definitely slowed down. All right. Hopefully that helped out, and I'll see y'all in class later on.